right. So I mean, we just barely got into stuff, so I don't know if anybody has questions from homework. If you guys have tried anything out yet. Yes, ma'am.
On part 2, number 21, I just want to get some clarification on it.
Oh, we haven't talked about the degree part of that yet. So I don't know if that's part of your question. Yeah, we really just barely got into 5.1, and then I did a real quick thing about polynomials. We haven't really done much in there yet. Any other questions before we get back into it? And we will be using the Blue Book a little bit today, so if you have that, that would make it easier. If you don't have that, you'll still be able to do it. In fact, we're going to jump into this very soon here. I just want to remind you guys. Well, let's do this. Let's look at it. Remind you. See if you remember. Alright, so if you got your Blue Book, it's page 84. If you don't have your Blue Book, it's still page 84, but I'm going to put it up here. So section 5.1 really just focuses on the properties of powers. So we went over this last time, and this should be something you've come in at least having seen before. There it is. Cool. Can somebody cut the light out? The one that's on the right side? Thank you. Alright, so real quick, try out those problems right there. This is page 84. And number 5, don't FOIL that out if you remember FOIL. Don't do that. Just put them together using exponents. No, just put these together using properties of exponents. So for example, the first problem, I don't want you to do 16 times 64. I don't want you to do that. That would be 4 to the what?
Yeah,
4 to the 5th power. So don't actually multiply them out. Just use properties of powers to combine them. So it's pretty much a you know it or you don't moment, right? And the biggest mistake people make is, for example, I don't know if anybody thought I was wrong in the first one, because you say, hey, Jeff, man, 4 times 4 is 16, dude. Just to let you know. And I'm like, all right, that's nice. But nowhere up there am I multiplying anything. I'm just combining how many 4s I've got, right? So I've got 5 total 4s that I see. So number 2, what's that?
3.3.
3 to the third.
Yeah.
Okay. Craziness, right? Because I had 2 3s, I multiplied another 3 by that, so now I've got 3 3s in a chain. I love it. What about number 3?
M03.
Yeah, 103. Now what about number 4? What's a little freaky here?
207.
Yeah, you could do 3 times 4 is 12. Right? They're not the same base, so you can't make it like 3 to the power or something. 3 times 4 is 12. And then I've got 7 x's. 2 x's there and 5 x's there, so 7 total x's. Cool. Alright. So how are we doing so far? So good? I mean, this should be a skill you come in with, but I just want to make sure we're all up with it. Some of us have had this skill a long time ago, maybe, and it's just gone. So I just want to make sure we're all there. Number 5 is a little freaky.
X6 plus Y.
Yeah, you gotta be careful.
X plus Y?
Now, how many x plus y's do I have? So I've got, no, careful. How many x plus y's do I have? 2 there,
And 4 here.
4 there,
6.
6 of those. Now, just because somebody said this, I want to make sure you understand this. This is you got to be careful. Everybody cool with this, right? So let me put this there. So can you see it? There, yeah. Now watch. What's this? This is not the same thing, is it? This is definitely not the same thing. But I'm just going to put this as an example. Not the same.
Yeah.
But what can I do here? I can distribute 6 times x and 6 times y. That's crazy. Now, the reason that works is because coefficients, what the hell do coefficients mean? What does it mean if I write, what does this mean, 6x? What the hell does that mean? Don't tell me it's 6 times x. 6x is doing what? What does it mean? 6x is doing what? I don't know, Jeff, dancing under a tree. What the hell? I don't know that song. 6x is, what are they doing to each other? What does that mean? That would be x to the 6th power, right? Exponents mean that I multiply several x's. That's what exponents are for. Adding. The coefficients were created so that I didn't have to write this. Oh my God, I get tired halfway through. So 6x means x added 6 times. So why am I allowed to distribute the 6? Because this is addition. 6, the coefficient means addition. And there's addition inside. They're going to play together well. You guys with me so far? What operation are exponents based on? Well, what did we just say? Multiplication. Are they going to play well with addition? Hell no. So I cannot distribute this 6. Does not know. It does not. It can't. But that's one of the biggest mistakes. It drives me a little insane. So at this level, you definitely have to firm that up, and then you don't want to make that mistake again. It drives people a little insane. So, for example, if I had, so that doesn't work. I just have to leave that alone. Or I have to write it x plus y 6 times and foil until I go insane. Right? So let's not do that. But real quick, what I get a lot is if I have 2 plus 3 squared, and I've seen this already in here. What is 2 plus 3? 5. So that's 5 squared, right? That's 5 squared. What's 5 squared?
25.
So there's no way in hell it's 4 plus 9. 25 does not equal 13. Right? That's groundbreaking, I know. But do you understand? Do you see that? I can't. How do I say this? I can't. So why am I allowed to? I can't break order operations here. And there's no other way to write this so that I can put those together directly. Why am I allowed to do this, though? Why am I allowed to distribute? Why am I allowed to break order operations there? Because I just write x plus y 6 times, blah, 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 blah. And then I add my x's together, add my y's together. That's why the 6 in front works well, because it talks about addition, and the things inside are already added. So they work beautifully together. This guy, they're talking about two different things. That's talking about multiplication, that's talking about addition. There's no shortcut for that. Maybe. Okay. What about number 6? And to the which one? 20th. Beautiful, because there's 5 ends, 6 ends, 9 ends. Add them all up, there's 20 ends. Kick ass. And then finally, number 7. Yeah, R to the 7th, good. And S to the 4th, because there's 1, 3, there's 4 S's total. All right, so when you multiply like bases, you add the powers, because all you're doing is you're just consolidating your count. I got this many R's, this many S's. There's some more R's. Oh shit, well now I got more R's. Okay, cool. There you go. Yes, ma'am.
So when do you actually, because in the book and stuff, you multiply the exponents, when do you bring that in?
All right, that's the next kind of level. And real quick, just to remind you guys, so we're going to work our way there. Here's stuff about the 0. Oh, yes.
Question.
Sure.
With that, is that the final answer, or can you say R is 11? No.
If you say this, you're telling me you have 11 RS's. You're telling me you have 11 R's and 11 S's. I don't have 11 of anything. Yeah, so why can I not combine these? Because the bases are different. Good. I like it. So if I had RS to the 7th and RS to the 4th, that would be RS to the 11th. Because now I have 11 of those things. Sweet. So I mean, I want you to understand, part of math is very much lower level than you kind of assume. It's just me saying, I got 2 R's. There's 5 more. Okay, now I got 7 R's. Woo. That's all that means. That's all that power means. So what about this here? We talked a little bit about 0 powers, and we kind of proved it a different way. But I like this. How do I get from here to here, from here to here? What do I keep doing? From 16 to 8. I divided by 2, and it makes sense. I had 4 2's. If I divide by 2, now I have 3 2's. So 2 cubed is 8. Divide by 2 again, I'll get 2 squared. Divide by 2 again, I get 2 to the first. Now what's 2 divided by 2? What's 2 divided by 2? 1. So 2 to the 0 must be 1. And that's what we learned last time. I did it a different way. I proved it a different way, but anything to the 0 power is 1. Let's see if you can really, really use it now. Do those real quick. What's that? 14 to the 0, so anything to the 0 power is 1. So it should be 1. You see? And then there's a mistake on number 3 also. So number 1 and number 2 are the easy questions in this set. Because the whole number that's there is being raised to a 0 power. So anything to the 0 power is 1. So number 1 is
1.
That's crazy. So 15 to the 0 power is 1. If I got no 15s, I got 1. That's all it's there. It's just a 1 sitting there. If I multiply by 15, now I got 115. 1 times 15 is 15. I've got 115. It's crazy. If I got no 15s, just a little poor little 1 there. The one that we normally don't write. That's all that's there. Here, I got no x's, no y's. So that's 1, yeah. Because what do I know? If I had 1 x and 1 y, what's in front of it? What's understood to be in front of that? What's the coefficient?
1.
1. We just normally don't write it because we're like, we're not crazy. I can see there's one of them, but let me write it. Now, if I took all my x's and y's away, I'm left with 1. There's a whole other reason why something to the 0 power is 1. If I got nothing there, I just got the understood 1 just sitting there, looking around like, what the hell? I don't know what it would sound like. What about this?
2
What's-
by 2 multiplied by 1?
Yeah, because what's being raised to the 0 power?
1.
So only that becomes
1.
and the 2 is just sitting there. What's 2? What power is 2 being raised to?
Nothing.
No?
1.
The first power. Right? So if I got the number 3 sitting somewhere, there's so many freaking understood 1s
One,
around this
yeah.
thing. There's an understood 1 times. There's an understood power of 1. There's an understood 1 underneath. Holy crap. A lot of understanding, hopefully. Right? So here, I know this is 2 to the first. It's just 2. 2 times this becomes 1, so it's just 2. Only the part that's being raised to the 0 power becomes 1. And the whole damn thing becomes 1. Whatever's being raised to 0. So number 4, what happens on the top?
1.
The top is 1 and the bottom,
9.
nothing's happening to the 9, so why would it change? It's just 9. So I've been known to be, I don't know, semi-evil. You guys are like, I know you're evil purely, so don't even quantify it. But I've done stuff like, we're going to get to the point where we're going to do stuff like this. And I'll put even some more stuff in there. Yeah, just load that thing down and maybe even make this freaky. Let's see. Blah, 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 blah. There you go. Yummy, yummy. Ooh. Goose. And then just 0. I mean, so I try not to do this. I'll do it on a bonus maybe. I'll have some bonus that has a part like this. Because I don't want somebody to waste their time. I mean, if you start doing this stuff on the inside, why is that a waste of time? Because the whole thing
Yeah.
is raised to a 0 power. So that is
1.
done, right? So why would you waste time on the inside? Whatever the hell the inside becomes, it's being raised to the 0 freaking power. So whatever it is going to be 1. So just jump to the end, right? Fast forward that thing. All right, maybe that's a little bit of a trick, so I try not to do that, except on bonus. Okay, so that's how the 0 power works. And the mistakes people make here are related to not understanding how far exponents go. They're related to this mistake. I think we talked about this already. What's the difference between these two things here?
-4.
Yeah, what's the first one?
-4.
Yeah, the first one is -4 because it's negative 2 squared. 2 squared is 4, negative out front. This one,
4.
I've got 2 -2's multiplied, the negatives cancel, it's +4. I like it because in the first one, only the 2 is being raised to a power. And the second one, the parentheses collect all of it together and raise the whole damn thing to the second power. I like it, I like it, I like it. Good, good, good. All right. So let's see. Here's the next level. Amanda, here's where things are happening. Like you thought they would eventually. So let me explain what's going on here. I don't like their screw their stuff. Let me do my own. So if I have x to the second cubed, what does something cubed mean? What does it mean? It's 3 of them multiplying, right? So this would be x squared times x squared times x squared. I got 3 of these. And what's x squared, x squared, x squared?
X6.
Yeah, 2 plus 2 plus 2 is 6. So now why the hell would I do this step? 3 groups of 2 x's, that's the definition of multiplication. How did you first learn multiplication? 3 crates with 2 apples in each crate. How many apples you got? And you're like, I don't know, I was hungry. Probably lost one somewhere. No. So I've got 3 groups of 2 x's. Of course I got 6 x's. That's the definition of multiplication. So this is when you multiply powers, when you raise them to another power. So what happens here in number 1? Yeah, it's 2 times 5. There's 5 groups of 2 x's, so there's 10 x's altogether. Then they snuck in number 2 to be a little evil. Yeah, anything to the 0 power is 1. Sounds easy. And of course, number 3. Y to the 30. Yep. Y to the 30. 6 times 5 is 30. Cool. If I wanted to get an 11th power, if somebody put 11 there, what are they thinking? They're adding. And what would it look like to make it y11? What should it look like? It wouldn't be written like this. How would it be written? Y6 times Y5. When I multiply like bases, that's when I add the powers. When I raise a power to another power, that's when I multiply them. I like it. And I know a lot of you guys know these properties really, really well. Just be patient. Hang out. Stare at your finger or whatever. Do something. The rest of you guys, I want to make sure we're all on the same page. So here we go. Here comes some nifty stuff. Those really, really look yummy. Alright, so take a minute and try those out. And just to make sure we all understand the shortcut here, you could take 5xy on that first one and write it 3 times. You could. But please, dear God, if I put a 30th power up there, I definitely don't want you doing that. Write it 30 freaking times. So here's the thing about from earlier. I couldn't distribute the 6th power across x plus y because the power is multiplication and inside there was addition. Now what's inside? What property or what operation is inside? What's the 5 and the x and the y doing? They're multiplying. And exponents are based on multiplication. So now I can distribute that 3. I can finally distribute that 3 because it's the operation it's based on is what's being used. Do you guys understand? I mean, not only do you have to remember the properties, but it'd be nice if you understood why they made sense. They have to make sense. So this would be 5 cubed, x cubed, become a 3. Y cubed. What is 5 cubed? 125, I like it. X cubed, y cubed. 11. So whenever I'm on the 125, being a math geek, I'm like, oh, it's the 5 cubed. All right. Sorry, I had to let you know that. What about number 2? What do I have to do first on number 2? Beautiful, because in order operations, powers or multiplication come first. Well, powers do. So I got to do that 3rd power and that 4th power first. So what would this become?
2 cubed.
2 cubed. X to the 6. Kick ass. Times.
X to the 12.
X to the 12th. Now this kind of problem is always a little more difficult because you got to shift gears, right? And I can often hear the grinding and see the smoke because we just multiplied powers because I was raising stuff with powers to a power. Now what am I going to do with those powers? You got to add them because now I'm multiplying like bases, right? So what is 2 cubed? 8. X to the 18. Kick ass. All right, let me shut up for a bit finally. You guys do 3 and 4.
Where did you get the 18 from?
What would this be? X to the... No. 12. See? And I get 6x is there, 12x is there, 18. Because you're multiplying, so you're going to add the powers. I like it. All right. Some of you guys have found your favorite piece of floor and you're staring at it. This is good. As long as you get something to do. Number 3, what's the only piece of that I'm not going to have the 10 effect? Because -2 is not being raised, it's outside. So -2 just comes for the ride. There's -2 just sitting there waiting. X to the what? 20th, good. Y to the 30th. Z to the 10th, crazy. Because Z is currently to the first power, 1 times 10 is 10, that's why it's now Z to the 10th. Okay, I like it. So you multiply powers when you raise something with a power to a power. Yes, sir?
You distribute the exponents first, right?
On number 4? Or just in general?
On 3.
Why did I do that? Why did I distribute the power? What's order operations say has to come first?
Exponent.
No. That's excused. What comes? Yeah, parentheses. Was there anything to do inside? No. So I like your question because look at number 4. Is there anything to do inside?
Yes.
Yes. So you might as well do that first. Order operations will say yes. Do you have to? No. You can go ahead and distribute the 2, but in general, it's a little bit easier if you simplify the inside first. Yeah.
Why would you not distribute the -2 to the Y and the Z?
Yeah.
Oh, okay. All right. Let me see if I can get. This is a good general question. I'm running out of blank space. All right. So if I had -2 times x10 plus y20, what would I do? Distribute. But if I have -2 times x10 times y20, there's no distribution to do here, right? What is 2 times 3 times 4? So it's not 6 times 8. You've only got 1, 2. How does it go to that piece and that piece? Only one of the poor things, right? So on this problem here, I've only got 1, 2. I can't put it on the x and the y. Now I've got 4. Where'd 4 come from? You guys see? If I put another 2 here, now I've got 4, don't I? I didn't have 4. I just had one poor little 2 dude.
So in a situation where it's multiple properties, multiple variables, that's not being added inside of parentheses. It's only distributed to the first.
I like it. So you only distribute coefficients when what's happening inside? Addition, subtraction, because that's what coefficients are based on. When do I distribute exponents? When there's multiplication happening inside, because that's what exponents are based on. I love it. Do you see how that makes sense? Let it make sense. I don't think that kind of thing's said enough. But that's why it works that way. And sometimes students are like, we didn't used to do that. The minute you think I'm doing something different that's different than what I did before, you got to let me know because it's not true. You're just not looking at it right. Math can't suddenly change just because it's Tuesday. Right? I don't care if we go to a whole new section. I can't do anything different than what I did before. I can only do new things. All right. Maybe. What about number 4? What can I do on the inside first? What's the only thing inside that I can do? Yeah, what's 2 cubed? 8. So the inside is simplified. Now I can square. What's -8 squared?
64.
Good, because the negative, of course, cancels. -8 times -8 is positive 64. M to the...
8.
Careful, n is to the 4th, so that would be to the 8th. M is to the first power, right? So that's m to the
2.
second. I like it. I just wrote my m and n really close. Yes, ma'am?
What about -2? Can I multiply 3 by...
Yes, okay, so if you did this, you're fine. So you just get the negative gets a little weird. Negative squared is positive.
Yeah.
And then 2 cubed, what do you do with powers? So that'd be 2 to the 6th, m squared, and 8. But 2 to the 6th is 64. So, see, it's just, that problem, there wasn't a lot going on inside. So it was just barely a little bit easier to get to 64 if you do the inside. But trust me, in general, do the inside first. Right? So we'll see examples. I'll show you examples. There's a lot of shit inside. I don't want to, and there's a 3 outside. I don't want to cube everything. If I just simplify the inside, I got less stuff to cube. That sounds good. I want to do that. I want to make less work. Oh, these aren't anything special. I don't know why they make them seem like they're special. And I don't think I've dropped this bomb on you yet. You guys realize that division doesn't exist? Oh boy, you guys are like, dude, man, come on. Stop doing that shit. But dividing by 5 is the same thing as multiplying by. Divide by 5 is the same as multiplying by
Reciprocal.
1/5, the reciprocal. Thank you. Right? So dividing by 5 is the same exact thing as multiplying by 1/5. So division is just something we made up to make it look easier, to make it look better, cleaner. What's my point with all this shit? I can put exponents inside. I can distribute them when there's multiplication inside. Division is freaking multiplication. So even when I'm dividing, I can still distribute the exponents. Because division really is just multiplication. So for example, that first one, I could do 4 goes to the 1. 1 to the 4th is 1. Beautiful. 1 to any power is 1. And 3 to the 4th, let me write it out. What is 3 to the 4th? It's 3 squared times 3 squared. 9 times 9, 81. So I can distribute powers across division because division really is just multiplication. Exponents are based on multiplication. They will play well with that. So you guys try number 2. Let's see. So distribute the 4th in. That becomes x to the 20th. Beautiful. We just did 3 to the 4th power, right? Negative 3 to the 4th power. 4 negatives make a positive because all the negatives kill each other, right? It's a weird Game of Thrones thing. And 3 to the 4th power we figured out is 81. And then I have how many y's now? Y 12. I like it because I multiply the powers. So that 4 just distributes in. Why did I start with a 4? What do I have to start with? I kind of skipped this step, but is there anything to do on the inside? There ain't nothing to do on the inside. So I can go to the next level, exponents, and bring that in. I like it. I like it. All right, so here. Let me unleash you on those.
Oh. That's silly. All right.
It's not a quiz. You can ask people near you if they got the same thing you did. Or if you're like, no, I don't trust those people, then just sit there and wait. Alright. So number one. What do you have to do first? Yeah, do the exponents here, right? Before I multiply, I got to do the exponents. So this is k to the 10 times k to the 18th. And that becomes k to the 28th, kick ass. Got to shift gears. Now, for some reason, this freaks some people out. I guess I'll jump over here. I don't like it. When you start doing this, but what's xy times x? What's the only thing you can consolidate there?
X.
Yeah, so it becomes x squared, y. I'm not sure. There's nothing more to it than that, right? xy times x. I can only multiply the x's, and I've got two of them now. There you go, x squared. Do you guys see that? Yes, ma'am.
Wait, why did you square the right?
I haven't gotten there yet.
Oh.
So that was just the first piece. Now we'll do the second piece plus xy squared. Now let me make sure I understood your question. Was that your question? Or, and the first piece, xy times x. xy times x. What's the only thing I have two letters of? X. In the second piece, xy times y. Now I've got two y's. That's xy squared. Now if you want to, just to remind you guys, so that's the answer there, you're done. But if you need to, or if it would help you, write xy times x plus xy times y. That's just I love that word, makes you sound good. That's just the distribution step, right? xy times x, xy times y, and now simplify each of those. Does that make sense if you need to? Especially if there's a lot going on. You come out to the same answer, thank God.
Can it be like x to the third power and y to the third power?
So, a couple things. The only time exponents can change is when you're doing what? What do I mean?
Multiplying like terms.
When you multiply, like bases, right? Or divide, because division is the same as multiplication. You guys with me? So there's two ways I can describe what you just said. One is, I'm not multiplying x squared in x, so there's no way that can become x cubed. And more fundamentally, are those like terms? What the hell are like terms? What the hell? What are like terms? Can somebody attempt to define that for me? What is it? Same variables and the same amount of each variable, right? So the first guy's got two x's and a y. The second guy's got one x and two y's. They're not like terms. I can't consolidate them. I can't say I got two of these, because I ain't got two of nothing up there. I got one of those and one of them.
So if there was an addition sign between x and y, and then the other x and y, you could add the x to the third, or
No. Okay. So if I have... So here's the interesting thing, and this is a nifty reminder. When I'm adding, I must have like terms. And those are not like terms. So again, two ways I can describe that. Those are not like terms. Plus, the only time I can make the exponent of 3 is when the problem had multiplication. That's the only time an exponent can change, because that's what it's based on. Does that make sense? So I got an x and an x squared. I got two of nothing. I got one of each. But if I had, let's try this. If I had x squared y plus xy squared plus y x squared plus xy squared. Are there any like terms?
yeah.
So who's like terms with this guy?
Y,
The first, second, third, fourth? Anybody?
yx.
Yeah, these are like terms. These are like terms. How many x's do they each have? How many y's do they each have? 1. Let me stop there for a second. You guys, You guys see what I'm saying? That's what like terms really is. And why is the second one okay? Why is it at y times x squared? I just didn't put it in alphabetical order. I just didn't feel like it. Or I was being tricky, which is more likely. Right, and I one time I had a student who just vehemently did not believe me that yx squared is the same thing as x squared y. But it's like saying 3 times 4 is not the same thing as 4 times 3. Who cares what order you multiply in, right? So those are totally the same thing. So what would I say? How many of these do I have? I got 2 what's? X squared y's. I got 2 of those. And of course I got 2 of those. And those at the end there are not like terms. I can't make 4 of anything. Kick ass. Are you guys with me on that? All right. What I always hate is when I have, x squared. Let me make something else. A cubed b plus ab squared, and somebody tells me I got 2a4b cubed. I'm like, right? And I always have to say something dorky like, I don't see any a4b cubes out there. How do you get 2? I don't see any a4b cubes, and this guy's got 2 all of a sudden. I don't. But those are not like terms. They don't have the same number of a's, the same number of b's. I like it. Maybe.
So the answer would stay the same, a3b plus ab squared?
Exactly. This. If I said simplify this, it's a little bit tricky because it's already simplified. You can't do anything. It's sort of like me saying factor 17. You're like, done. Can't do anything. Okay, maybe. But see, this is why I don't think you guys. Some of you guys just don't realize what I'm saying. Combining like terms is just a human thing to do. Why would I go? How many people in that row? Well, there was a person and a person. No, combine them. There are 7 people in that row. Just put them together. Dear Lord. So this is where I'm saying here. I'm saying, well, there's an x squared y and there's another x squared. No, just say there's 2 freaking x squared y's. What are you doing? I got to go somewhere. Do you guys understand? It's a very human thing to do. Combine the things that are alike so you can say something quicker. I got 4 tables and 3 chairs. Not, I got a table and a table and a table. And who are you? You have 4 tables. Stop doing that. Do you guys understand what I'm saying? There's nothing magic. There's nothing to not be understood. It's just what we do. It's what humans do. One thing that we do. Thankfully, it's not all we do. All right. So coming back here, what about number 2? Good, because there's nothing to do inside, right? So then I can multiply the powers here. And this is where things get a little weird. I'm not picking on anybody. But 4 times 4 is 16. 3 times 4 is 12. And then I'll get this. And why would somebody think that? Because what did you just do? You just multiplied numbers, and your brain gets in that mode. Multiplication, here we go, multiply. It's like, whoa, dude. Why did I multiply the tops? Because they're powers. That's how powers work. Powers are not going to work the same way as just numbers do. Of course not, right? So what should be on the bottom?
16.
Yeah, it should be 2 to the 4th, which is 16. Right, 2 to the 4th power. I love it. And of course, when I write this, I did apply the same property. What's the power on the 2 inside? 1. 1 times 4 is 4. There, I applied the property. When I write a number to have a power, it will have to follow the same properties that powers do. Because now it's got a power on it. I don't know if you guys see what I'm trying to say. So in that problem, there was no 4 in that problem at all. There are 4 A's and then 4 of those things. Right? There's no number 4 in there at all. All right, what about number 4? Sorry. That's the same thing as number 3, just with a little more stuff going on, right? So in this first grouping, what can I combine?
2a.
Yeah, 2, a third, because I got 2 more. I got 1 there, so now I got 3. And then the b, I just got the 1b from out there. Minus 3. How many a's do I have now?
3.
Good. A cubed. And how many b's do I have now?
3.
B cubed. Kick ass. And of course, those are not similar. They're not like terms, so I can't combine them. I like it. Maybe.
So, with the a squared b, you're not gonna multiply with the 2a or not?
Yeah, we did. What's a squared b times 2a? It's 2a cubed b right there. So again, if you want to, let me do this problem again a little bit here. If you need to or want to, you could just write, before you do any multiplication, you could just write, I'm distributing a squared b to 2a, and I'm distributing a squared b to 3ab squared. And now attack each one of those. This will be a cubed. I put the 2 out front, that's just convention. I put the number out front, 2a cubed b. And this will be minus 3a cubed b cubed. I'm just combining what I can. All right. Maybe. Now let me ask you this, because people often come back at me with my example of the chairs and the tables, and they say, well, I got a chair and I got a table. I got 2 pieces of furniture. I put them together. Ha ha. All right, dude. Jeez. Call it. In that second term, how many A's are there? 3. How many B's are there? So if I ask you how many total letters are in this term, what would you say?
2.
There's 3 A's and 3 B's, so there's 6 total letters, right? It'd be A, B, B, B. You guys kind of with me? Is there a way to represent mathematically what I just said? No. I can't say there's 6 letters. I can't write that in Mathish. You with me? So in English, I can just say, well, I got a person and a chair and the carpet. I got 3 things. We can just say things. That's nice for English. Math, it doesn't really help us out in math. I don't know if you guys see what I'm trying to say here. Just to nip that in the bud in case somebody comes up with that. Got it. There you go. All right. So now, if we understand like terms, this whole section about addition and subtraction of polynomials should go pretty smoothly. So just putting your like terms together is really all it's about. We already talked a little bit about this. Who remembers this? If it has one term, what do I call it? Something with one term, what would I call it? Monomial. Kick ass. 2 terms. Binomial. By the way, this is page 87. 3 terms. And thank God we stopped there. Anything beyond that, we just call it polynomial, meaning many terms. We're like, that's enough. In fact, there were entire civilizations, the only numbers they knew were 1, 2, 3, many. That's all the numbers they had. 1, 2, 3, anything more is like many. Leave me alone, I got time to count that. Alright, now let's see who remembers what makes a polynomial. How many of these are actually polynomials? What's definitely not a polynomial? All right, second I like, but the last one is definitely not, because that's exactly what I said last time. What cannot happen in a polynomial? My variable cannot be on the bottom, right? Yes, sir.
The third one over.
Third one, why do you think that one's not a polynomial?
Wait, is it?
Oh, good, I like it. Okay, thank God. So, this one is a polynomial for sure, because it's a collection of terms that are made of numbers multiplied with variables that are raised to whole number powers. Man, that's a lot of things I just said. But basically, a polynomial, the variables can only have whole number powers. So this guy would be a -1 power because it's underneath. We talked about -1 is when we flip things. So that's not a polynomial, no good. This one is a polynomial, that's fine. Why is this one not a polynomial? It's got a fractional power. We don't even officially know what the hell that means yet. Shit, but a polynomial's got to have a whole number power. It can't have a fractional power. So it's out. Damn. So that one's good, and this one's good. Those are polynomials. The other two, no. I like it. So here's why. Oh, yes.
Why is the first one a polynomial if it only has 3 terms?
Oh, okay. So monomial, binomial, trinomial are more specific names we give to certain polynomials.
Okay.
they're all polynomials. It's just that first one happens to be more specifically a trinomial. So like saying, that's a bird, somebody else goes, well, that's a yellow belly. Yeah, who are you? That's a bird. What do you want? Right? All right, I like it. Or when I said to my friend who painted their kitchen, I said, oh, you painted it green. And she's like, I painted it forest blood. I'm like, it's green. Leave me alone. Sorry, it's green, okay? That's just me. Okay, so here's the idea of degree. And this is why I said earlier about, I can't say a cubed, b cubed is anything to the 6th power, but you can say that there are 6 letters in it. So the degree of a term, I don't like the way they say this. Let me do it up here on the board. The degree of a term is the total number of variables in it. So for example, this term here has how many variables in it? 2, 1x, 1y. So this would be a 2nd degree monomial. Right, to really make it sound freaky. This is a 2nd degree monomial. To be really specific. Right. So what about this term here?
Third degree.
How many total letters does that term have? It has 2 A's, 3 B's, and a C. 6. It's got 6 letters total. So the idea of degree, I'm not writing something mathematical. I'm actually doing like we said earlier. I'm describing the term. It's got 6 things in it. Sort of like if I had a stapler and a thing, 6 things. That's the 6.